That's good. It's recording now. Okay, perfect. So what are we doing next? So now you don't see that Twitch anymore. Okay, awesome. That's gone. Okay, great, great, great. Thank you. Thank you. Okay, perfect. And I see now the camera, and it's not twitching, correct?
Nope, it's all good.
Okay, awesome. That's what it was. Okay, so now I'm going to record with the tablet, and I'm going to have my laptop on. Okay, good. We're in business after 35 minutes. Sorry. Okay, so tell me what to do next. What are we working on next? And now I see it's clear, right?
Yeah, the video quality is a lot better.
Okay, so I guess there was some sort of conflict with the cameras, one and the other. Some sort of software glitch or something. Okay, excellent. So do I need to adjust? Do I need to adjust here the zoom?
It looks really clear to me. I mean, the red's still kind of light, but I can still see everything.
Okay, I will not use the red anymore. It's actually it's pink. That's why I'm putting it aside. Okay, ready? I got a sip of water. I'm ready. Do I choose, or you want me? You want to choose?
You choose.
Okay, I will choose. Are we okay with long division now?
Yes.
Okay, so I'm going to the end of chapter 3 to pick some problems from there. End of chapter 3 for sections 3.1 through 3.5. Actually 6, but we didn't finish the last 2 sections, so we can look at those. Okay. Do we want to look at the graph? Graphing a polynomial function. We want to look again at the quadratic function. Okay, let's look at problem 7 on page 456. And, oh no, I forgot to turn off my phone. They're all crazy today, absolutely all crazy. Oh, it's one of your colleagues, I'm sure. Hello? He's offering me an interest rate. So we have a quarterback tosses a ball to a receiver 40 yards downfield. The height of the football, f of x, that's the height, in feet, is negative 0.025 x squared plus x plus 6. This is the function. The reason I left the phone on is because some of you guys cannot get in and I get phone calls. So that's the only reason I left it on. So x is the ball's horizontal distance. So x is in feet, horizontal distance. And the horizontal distance is in yards, but the height is in feet. What is the ball's maximum height and how far from the quarterback does this occur? So the first question is asking us to, the first part is asking us to find the maximum height. I'm looking in the video now to see what I'm doing here. Okay, so maximum height. So for the maximum height, first of all, I have to look at the function and identify the fact or realize that the function is what type? The function is?
Quadratic.
Very good. Since the function is quadratic, we know how to find the maximum of a quadratic function. How do we do that?
Negative b divided by 2a.
Very good. That's the x coordinate. I'm trying to see if I can get this better positioned. Okay, so we are really finding the vertex, which is negative b over 2a. Negative is from the formula. B, make sure that this is arranged in descending order, because only then you can identify b correctly. Is that clear? So then b is 1, and 2 times a, 2 times this number is negative 0.005. 0.5, yes. Obviously, the distance has to be a positive number, and it will be. So the easiest thing, you can use the calculator, but we always have to remove decimal numbers by multiplying the top and the bottom by 100. So then I have 100 divided by 5. So obviously this is 20. And this is x. We're talking about 20 yards. But this is not the maximum height. This is basically, can you see? So basically, this is 20 yards. But this will be the maximum height. How do I determine the maximum height? Which is this. How do we determine this? Well, we have to plug in 20 in the function. This will be f of 20. Once we have x, we always determine y by plugging it in. So f of 20 equals negative 0.025 times 20 squared plus 20 plus 6. So we can use the calculator. And with negative 0.025, I can square 20. I can square 20, and that's multiplied by 400. And then I can add these two. It's positive 26. And I got 16. So 16 is this. But this is in feet. Any questions so far?
No.
Okay. Now, part B of the question. From what height did the quarterback toss the football? Which is this. How do I determine this height? What does that represent for the function? And then I know how to determine it.
The y-intercept.
Exactly.
So x equals 0.
Very good. So this will be determined with f of 0. Very easy. Where is my function? I put it aside. 0, 0, how high?
6 feet.
6 feet. So this is 6. The next question is asking, I don't have enough room now here because the tablet is in my way. If the football is not blocked by a defensive player, nor caught by the receiver, how far down the field will it go before hitting the ground? Round to the nearest tenth of a yard. but I will make other arrangements here so I can have more room. So now we are really asked to find this. You cannot assume that this is also 20, because remember, the axis of symmetry, this distance equals this distance. Not perfectly in my figure, as you see, but this cannot be 20. Right? So this will equal this, not this. So you cannot draw conclusions that that is another 20. So please don't do that. Did I lose you? Can you see?
I can still see.
Okay.
Yeah.
Good. And it's recording beautifully. Okay. So how do I determine how far down the road the ball hit the ground, assuming it was not intercepted and there was nobody there to catch the ball? What am I asked to find now?
The X-intercepts.
The X-intercept. Yes, both. But this will make no sense for us. Only this one is the one that we are interested in. Very good. Awesome. How do I determine the X-intercepts for any function?
The quadratic formula.
Yes, but because I have to set f of x equal to 0. So f of x is negative 0.025 x squared plus x plus 6 equals 0. I think that that was the function. Yes. You know me, I do a lot of preparation before I put this in the quadratic formula. Do you have to go through all those steps? Not necessarily. I recommend them though. So first of all, I will multiply by negative 1,000 because there are 3 decimal digits here. That's why 1,000, 3 zeros. So this is x squared with 25 in front, and this will be negative 1,000 x, and this will be negative 6,000 set equal to 0. So this times negative 1,000 is just 25. 1 times negative 1,000 is negative 1,000x. 6 times negative 1,000 is negative 6,000. And of course, I'll divide by 25, everything, to get rid of that. So then I have x squared minus, and when I divide 1,000, I don't need a calculator, but when you divide 1,000 by 25, you get 40 x. When you divide 6,000 by 25, you get 240. So we divide it by 25. And this is more human. Easier to put in the graphing calculator. So this is x equals negative b. Stop if you have questions, please. Plus or minus the square root of b squared minus 4 times 1, that's what I really like, times this, which is negative. I don't want to put parentheses and write negative 240. Instead, I'm going to do this. Because there are 2 negative numbers, they will change into positive, over 2 times a, which is what I like. So now remember, when we put in the graphing calculator, we need parentheses and parentheses. So parentheses around for the numerator, I put 40 plus the square root of, you know me with parentheses. So 40 squared plus 4 times 240, close the parenthesis, go outside for another parenthesis to close the first one. And now we divide by 2. And we press enter. And I got 40.59. So x equals 40.59. And then this is in yards. Sorry, x is in yards. Yes. And there is no point in finding the other one, but let's find it with second and entry, second and entry. and change the plus into minus, override it. Minus and press enter. Of course, I was expecting a negative answer, negative 0.6, negative 0.59 yards, which obviously is this right here, but we don't care for it. So this is what we wanted. We wanted to determine this 40.59. Okay, final question in this problem. Graph the function that models the football's parabolic path. It's a parabola. It's called parabolic path. Fine. So when I graph, I know that this point is 40.59. This one is 20. This has to be 6 feet, and this has to be 16. So let's see what type of unit I'm going to. So I'm going to say 10, 20, 30, 40, 40.59. This is the X, one of the X. Sorry. I hope you can see. So this is 40.59. When X is 20, when X is 20, there is a maximum, and the maximum is 16 feet, and this is 6. So 2, 4, 6, 8, 10, 2, 4, 6. So this is 16, and 2, 4, 6, and that's the graph. So this is 40.59, and this is in yards, and this is X, and this is Y, and it's in feet, and this is 6, and this is 20. So this is the graph, and obviously it's a parabola. There is no point in graphing the other X-intercept, because he's standing here, he's throwing. Now, I have to admit that this is a little bit deceiving, because this is in feet and this is in yards. So be careful. It's basically more like this, but because obviously a yard is way bigger. But this is the idea. This is the graph, assuming that I use this unit for yards and this unit for feet. But it's slightly deceiving. Yes. Next question, next type of question, anything. Should we go back to the previous test for other questions? Yes, other questions from the test or something else that you would like to go back to? I'm looking to see, we looked at the domain. Oh yeah, we didn't decompose. You want to decompose that function from 8?
Yes.
So in number 8, we have h of x, which is 1 over 4x plus 1. So they want us to find an inner and an outer. The inner is denoted by g of x and the outer by f of x. To decompose this function into an inner, which we'll apply first, and an outer, which we apply second. So that will be one problem that we didn't look at yet. And then we can look at the equation of the circle to review chapter 2, the second half. So can anyone give us an idea for the inner and the outer? What could an inner function be? So what would be the inner?
4x plus 1.
4x plus 1. And once we get a number for this, we have to apply the function 1 over x. How do I check this? Oh, I have to determine f comma g.
So do you plug into 1?
Yes, so it will be f of g of x, which will be f of 4x plus 1. And since f says 1 over blah, it's 1 over blah. What about the next problem, which is the equation of the circle? Yes? Any questions on this? Is that okay? Okay, let's look at the equation of the circle then. So we have a center, -1, 3, and the radius is 2. Okay, it says we're running out of time in 10 minutes. I just wanted to tell you. I hope moving forward we're not going to have this problem because, as I said, they are buying licenses now for us. Okay, so what do we do? We're asked to write the equation of a circle that has this center and this radius and eventually graph it. Well, I can start by graphing it very easily. I start with -1, 3, and I create 4 points around the circle. 2 units away, 2 units away, 2 units away, and 2 units away. Why? Because the radius is 2. So here it is. But I'm also asked to find the equation of this circle, and I am also going to ask you what is the domain of the circle. It's not a function, but what is its domain and what is the range? So remember the equation of the circle, it's x minus h, everything squared, plus y minus k, everything squared, equals r squared. Where this is 2, this is k, which is 3, and this is h, which is -1. So the equation of the circle for these conditions will be x plus 1 everything squared plus y minus 3 everything squared equals 4. And can anyone identify the domain and the range?
The domain is
-3, 1.
Very good. So this is -1, 2 to the left and 2 to the right. And this is +3, 2 down and 2 up.
so it would be the range would be 2 and 5.
1, 5. 3 minus 2.
Sorry, 1, 5.
Yes. 3
Okay.
minus 2 and 3 plus 2. Great job. Good. Do we want to continue with something else from the test or from something else? Anything from my math lab? Let's find the distance. Is that okay? Should we find the distance? Do you want to graph number 12? You want to find the distance and the midpoint?
Yeah.
Okay, so we are given 2 points, -2, 0 and 4, 6. And we're asked to find the distance. And that's basically the same formula. But the square root of x2 minus x1 everything squared plus y2 minus y1 everything squared. The easiest is to even start with the midpoint. You have to add these two numbers. When we add -2 to 4, what do we get? Divided by 2.
1.
We have to add these two numbers. We get, and we divide by 2.
3.
That's it. So now in order to find the distance, I will replace, I will call this one x1, y1, and x2, y2. So I have 6 minus 0 and 4 minus -2. So the distance is the square root of, how much is 6 minus 0?
6.
6 squared
36.
plus 4, but minus -2. 4,
7.
so 4 minus -2 is 6. 6 squared is 36. So this is what I recommend. Don't add 72 and get 72. It's better to say that this is the square root of twice 36, because the answer may be required to be in exact. So this is the best. If you write 72, that's fine, but you still have to come back to 2 times 36 so you can take the square root.
Isn't the problem when you said x2 and x1, aren't those the y variables?
You mean here?
Yeah. Isn't the x2 supposed to be 4 and then x1 is -2? Instead of those being...
I switched them, you're right.
And then for 4
It's the
minus
same,
2,
it's the
isn't it
same.
4 minus -2, so it's plus?
Yes, so that's why it's 6, which is squared.
Oh, okay. Sorry.
Yeah. I'm sorry. I should have started with x. So 4 minus -2. So this is x. Thank you. Yes, it's the same thing, but you're correct. So I should have followed the rule. So it doesn't matter which way you add them, either y. But I should have followed x2 minus x1, y2 minus y1. I started with y. No excuse. Doesn't change anything, but that's not what I said. So let me write it one more time just for everyone to see. So the correct should have been 4 plus 2 everything squared plus 6 minus 0 squared. So that doesn't change the answer, but this is the correct. So it's the square root of 36, again plus 36, and that will still give us that. But this should have been the first, and this should be the second. It doesn't matter. You can still write the same thing because addition is commutative. Any questions? We may get cut off soon. As I said, I hope next time we meet online is not going to happen. Anything else? Any other question? Anything else that you would like to go back to? So I'm going to email everyone this today, tomorrow, about taking the test on a Saturday or Sunday instead of during class time. So our test is scheduled for April the 15th, test 2. But I like to move it either Saturday or Sunday. Anytime you want. I prefer in the afternoon if possible. But any time you want, 18th or 19th. So we do not take instruction time